is 2011 4B. A smooth pulley of mass 2 kilograms. So look, that means the pulley is going to be going down itself 2 mg. Okay, and it's a smooth pulley of mass 2 kilograms connected by a light inextensible string passing over a smooth fixed pulley to a smooth pulley of 5G. So this one here is 5G going directly downwards. I think I might make this diagram a wee bit bigger because you need a healthy size diagram when doing this. Okay, so let's try this again. 2 mg or 2 mg going down. Oh sorry, just 2G.
No, that's
oh sorry. Yeah, it's a fixed pulley, so that doesn't matter. So sure, actually has a label for you. 2G here, 5G here, 1G there, 3G there, and then we're going to have 4G and 6G. Okay, now we're going to have to now label basically our tensions. We'll call this one T1. T1 is the same that's the same string. And then T2 shall be the in the 2 gram system, the 2 kilogram pulley. I'll label it in a different color, T2 in green. And then finally T3 in purple. Okay, now we're going to have to put some accelerations in as well. Okay, so which one will be which? Okay, so 6G minus 2G. Okay. Let's do this as B. So you're going to be A. Now, which system do you think is going down? The 5 is going down and D. So I'll do A like this. The 5 is going down and the 2 is being raised upwards. Then within the pulley themselves, what's happening there? The 3G is going down at acceleration B, while the G is going up at acceleration B. And then in the other one, the 6G is going down with acceleration C, while the 4A is going up with acceleration C. So that's our system, okay? So what we're going to do is we're going to label which one we're doing. We're going to take the, we'll take the 6G particle starting off. Now, the 6G particle, which direction is it going in? Yeah. It's going directly downwards. Okay? Now, force equals ma. Its mass is 6. Its acceleration is the acceleration of the pulley it's on, which is A. Its own individual acceleration of C. So it's going to be 6 multiplied by A plus C. And that will equal its weight going downwards, which is 6G, and then the only thing that's been attached onto it is T3 going upwards. Okay, and that is the 6G particles equation. Now we're on the 4G particle. Now you have to make a choice for the 4G particle, and you can't make the wrong choice. Overall, do you think it goes up or down? And the truth is you don't know. Because you don't know if C going upwards is bigger than A going downwards. You just don't know. So you'll make a choice. Let's choose that overall it goes down. Okay? So overall it goes down. Mass by acceleration is going to be 4. Now if I've assumed it's going down, which one's bigger? A or C? For the 4G particle? A. Because C is going upwards, okay? So it's going to be A minus C. Okay? 4 times A minus C equals its weight going downwards, which is 4G, minus T3. You'll notice in the marking scheme to the right here, they have the exact same equation, except the opposite way around. They assumed it was going upwards. Bottom line is, it's the same thing as multiplying both sides by minus 1. You still actually end up with the same equation.
Why is T3, should T3 not be bigger than 4G?
No, because I said the particle was going down overall. If you did it that way, Garrett, you'd have to put down c minus a. You'd say that your acceleration is going upwards. If tension's winning, it's going upwards. Okay, that's the equation for the 4g particle. Okay, now we're going to go for the equation of the 3g particle. Okay, so the question says, find the tension in each string when the system is released from rest. Okay, so now we're going to go for the 3g particle. Okay. Picking up easy marks all this time. So 3g particle, which we'll do in red. So the 3g particle is going to be, 3g particle is going up, but it's also falling down at the same time. So do you know what? You can pick it either way. I'm going to pick that it's going down, just because it's easier to keep it in line with the other ones. So I'm going to be doing 3 times b going downwards minus a. 3b minus a equals, that's going downwards, so its weight is winning over tension. So it's going to be 3g minus t2 going upwards. And then finally I'm on the 1g particle, which I'll do in purple, or the 1 kilogram particle. Okay, and the 1 kilogram particle is most certainly going up. It's going up with A and B as its acceleration. So it's going to be 1 times A plus B, which represents mass by acceleration. Its tension is pulling up, which is T2, and its weight is pulling it down, which is 1G, going downwards. Okay, now I basically have a lot of equations here. Okay. So what I'm going to have to do next is I'm going to have to find out the pulleys now. The pulleys is the next one I'm doing. So what I'm going to do next is, what's it, a 2 kilogram pulley, is it? Yeah. I'm pretty much running out of colours here, right? So 2 kilogram pulley. Now let's zone in on the pulley. It's T1 going up, but according to the pulley, now you got to draw out the pulley because the pulley is very important. The pulley has T2 pulling it down, not the weight of, it's not the weight of the particle taken from it, it's how it's connected. It's connected via tension. T2s are dragging it down. Its own weight is 2G bringing it down, and T1 on the way up. Okay, and overall, what are we saying about the pulley? Overall, its acceleration is A, isn't it? So it's going to be 2A, MA is your force, 2A equals, 2A going upwards, equals T1 going upwards, minus 2T2 going downwards, minus 2G also going downwards. Okay, and there it is there. Now we're on the 5A, the 5 kilogram pulley. On the 5 kilogram pulley, is going downwards with an acceleration A. It's getting held up by T1, getting dragged down T3 and T3 twice, and getting dragged down by its own weight 5G. Mass by acceleration is 5A. 5A equals T1 acting upwards. Upwards is not winning, so you have to start off with downwards. 2T3 going down. Your 5G is also going down, and your T1 is going up, and that's why it's opposite in sign. Okay. Doing this, it's best to label what you have. Okay, so you're going to label all. You're going to get all your equations together, and you're going to start labeling them. Okay. So we have here. We'll call this A and B. Okay, then we'll go up for the other ones, and we should probably multiply this out. That's going to be A plus B equals T2 minus G. We'll call that equation C. Now we're on equation D. Equation D is the next one up. It's going to be 3B minus 3A. 3B minus 3A equals 3G minus T2. Okay, next one after that is going to be 4A minus 4C. 4a minus 4c equals 4g minus t3. And then finally, after that, we're going to have 6a plus 6c equals 6g minus t3. That's E and F. Okay, now you now have to systematically figure out what are we looking to find out. What is the purpose of the question? Find the tension in the string when the system is released from rest. Okay, so what we have to do is we have to systematically try and eliminate out numbers and find out what the acceleration is. I say we're best off trying to find out what the acceleration is first. So what I do here is add A and B together. So equation A plus equation B. What happens when we add A and B together? You can get rid of T1 right away. So what we get is 7A equals 2T3 minus 2T2. 2T3 minus 2T2 plus 3G. Now, I'm looking at these and I'm going, if I can trade out T3 and T2 and replace them with A and G, I'm in business. Well look, equation C does exactly what I'm looking for. And so does equation, that's T2, that one does. What about T3 in terms of A and B? I can't get a T3 in terms of A and B. I'm going to be left with a C unless I join them together. Alright, here's what I'm going to do. Right, 7, I want A but I don't want B. That's what the problem is, right? I want A but I don't want B. So look, here's what we're going to do. Do you see equation C and D? See equation C and D? I want A but I don't want the B. So I'm going to set this up in such a way that the B's will cancel in a simultaneous equation. So what I'm going to do is I'm going to multiply the top and bottom by 3. So I'm going to get 3A plus 3B equals 3T2 minus 3G. This is 3C, 3 times equation C. Now I'm going to do minus D. Minus equation D will give me 3A minus 3B equals T2 minus 3G. Now all of a sudden I'm going to have 6A equals 4T2.
It's not 3G minus, it's 3G minus T2.
Which one?
D.
D. I did minus D. So it changed T2 into plus T2 and 3G into, I multiplied both sides by minus 1. So now I'm going to get 6A equals 4T2 minus 6G. Okay, and that's exactly what I wanted. And now I'm going to isolate T2. So I'm going to get 6A plus 6G equals 4T2. And if I remember correctly, I'm looking for 2T2. So I'm just going to divide by 2. 2T2 equals 3A plus 3G. That's half it done. Okay? And also I substitute in was A and G. Likewise, I'm trying to get rid of T3. And when I look at T3, what's happening is, for T3, I want to not use C's if possible. So to not use C's, what I'm going to do is going to multiply equation E by 3. So to get 3E, I'm going to get 12A minus 12C equals 12G minus 3T3. And then the next we're going to multiply by 2 to get 12A plus 12C equals 12G minus 2T3. Add them in together and I'm going to get 24A equals 24G minus 5T3. Okay? Move it around. 5T3 equals 24G minus 24A. Alright? And then what is T3? I might as well get it on its own. So 24 over 5G minus 24 over A times 5. Okay. Now, these two equations here are very important. to solving this equation up here. Okay, so we're going to bring it down here. Okay, and plug it in, and let's manipulate and hope we get this correct. Okay, part 1, 7a. 7a ends up to be 2t, is that 2t3, is it? So it's going to be 2 times 24g over 5 minus 24a over 5. 2 minus 2t2, which is minus 3a plus 3g plus another 3g. Those 3g's will cancel. And then we're going to multiply, I'm going to multiply everything by 5, so I'm going to get 35a equals 48g minus 48a. And then I'm going to multiply that by 5 as well to get minus 15a. Now that is going to be, minus 6, that's going to be 63g, isn't it? 63g plus 63a plus 35a is 98a. 98a equals 48g. What does a equal? 48 divided by, what's 48 divided by 98, just out of interest?
24 over 49.
Was it?
24
24
over 49.
over 49 multiplied by 9.8?
4.8.
Perfect. 4.8 ms to the minus 2. I've now found out what a is. Okay? Now the fact that I found out what a is means I can now find out what t2 is. So t2 is going to be t2 equals 3a plus 3g all over 2. And what's t2 is going to be 3 times, what's it, 4.8 plus 3 times 9.8 all over 2. And what does that get me? 21.9. T2 is 21.9 newtons. Okay, now I'm on to T3. T3 is 24 over 5g. So 24 over 5g times 9.8. And then minus 24 over 5 times a, which is 4.8. What do you get there? We now know that that's 24 newtons, and finally brings us back up to T1. And now T1, where's our equation for T1? Trying to find. Now we eliminated out T1 at the start, didn't we? But here it is here. So what we can do is with T1 is we can say that T1 equals 2a plus 2g. I'm using equation B plus 2t2. So what's that going to be? It's going to be 2 times 4.8, 2 times 9.8, and then what's 2t2? What's t2 again? 24, was it? 2 times 24? So this means that T1 is 77.2, which is 77.2 or 73? Looking for it to be 73. Let's see if we got everything right here. 2a, which is 2 times 4.8, plus 2 times g, which is 2 times 9.8, 2 times t2, t2 is 21.9, excuse me, that's where I went wrong, t2 is 21.9, and that will get me 73, t1 is 73, 3 newtons. Okay, alright guys, that's that question done.